All right, let's review for our test. What I would encourage you to do is pause it, do these questions, and replay it to go over your own work. So try these questions first. Take a couple minutes. Here are some compositions, and here are some inverses for you to work on. So pause it, work on these, and then when you're finished, play through the completion of these. So this composition symbol here is a Q to change the notation to parentheses notation. If you have no difficulty reading that this is asking you to plug F into G, then that's okay. But I would encourage this notation because now we can see the inside parentheses is f of x, and f of x is x plus 5. So let's plug in x plus 5 for its equivalent, f of x. So this question is really asking you to find g of x plus 5. Now that's asking me to go to the function g and rewrite the rule for g with an open set of parentheses for both of the x's. So g of x plus 5 is x squared plus 3x. G of x is x squared plus 3x, so g of x plus 5 is x plus 5 squared plus 3 times x plus 5. Just remember, when you square by, you get a trie, so this is asking you to FOIL x plus 5, and if you FOIL it correctly, you should get x squared plus 10x plus 25. Let's distribute this 3. 3x plus 15. And now we have some like terms to combine. We have a 10x and a 3x, a 25 and a 15. So g of f of x is x squared plus 13x plus 35. So now let's just expand on this a little bit. If they had asked me for g of f of 1, well, there's two ways I could do this. I could plug 1 into f, 6, and plug that into g. So f of 1 is 6, so g of 6, 6 squared is 36, 3 times 6 is 18, and 36 plus 18 is 1454. So therefore, g of f of 1 is 54. And if I had plugged 1 into this, I would have gotten the same thing. So numeric evaluation, you can do it piece by piece. Find f of 1, get yourself an output. That output is now an input for g, and the output now is your output for the whole thing. Or you could find the rule for the composition and plug in 1 to the rule for the composition. If you don't have to find a rule for the composition, then I would encourage you to just do it piece by piece. Alright, let's find some inverses now. If we have f defined by the function the square root of 3 minus x, let's find f inverse of x. First, y equals radical 3 minus x. Now we can interchange x and y. This notation, we don't have an x and a y to interchange, but we're smarter than that. We know that f of x is y. So now we can interchange x and y's position. Nothing is moving with x and y. We're simply interchanging their positions. So we have x equals radical 3 minus y. And now we can solve for y. So we want to get rid of this radical, so we have to square both sides. X squared equals 3 minus y. When you square a radical, it simply gets rid of the radical sign. Let's subtract 3 from both sides. X squared, x squared minus 3 equals negative y. Don't forget that negative. And now multiply both sides by negative 1. So negative x squared minus 3 equals y. And if we wanted to, we could distribute the negative here and say negative x squared plus 3 equals y. Now let's be a little more specific than that and say f inverse of x equals negative x squared plus 3. Let's just be a little more specific than just y equals. We found something which was the inverse of f. So say f inverse equals. Now, if they had asked me initially, maybe not find f inverse of x, let's say they had asked me for f inverse of 1, well, that's asking me to plug 1 into the inverse of f for x. So we found f inverse of x, which means f inverse of 1 is negative 1 squared plus 3, which is negative 1 plus 3, which is 2. So this notation here is simply asking me to find the inverse first and then plug in 1. Okay, again, why don't you pause this video and prove that these functions are inverses of each other. So pause this, work on that. When you're finished, go through the video to make sure you did it correctly. So hopefully you've completed the question. And if we're trying to prove that these functions are inverses, then what we'll do is find both f of g of x and g of f of x, and we should get x in return in both directions. And if they are, then yes, they are inverses. If they're not, not inverses. So let's find f of g of x. Let's change this notation to f of g of x so we know where to begin. G of x is the innermost parentheses now, and g of x is all of that. Let's plug this in right there. So we want f of x minus 5 over 2. Here's the rule for f. F is 2x plus 5. And now for x, I'm plugging in x minus 5 over 2. So the 2's can cancel here. So we have x minus 5 plus 5. Now the 5's cancel. X. So far so good. One more direction to go. And then we could say that these functions are inverses. Only if we get x the other way. So now let's find g of f of x. Well, here's f of x. 2x plus 5. Here's f of x. So this question is really asking us for find g of 2x plus 5, because f of x is 2x plus 5. This notation is asking me to set up g with an open set of parentheses for x. So g of x is x minus 5 over 2. And now we're plugging in 2x plus 5. So we can rewrite that as 2x plus 5 minus 5 over 2. The 5's cancel. 2x over 2. Cancel the 2's now. X. So we got x in return by composing the functions in both directions, which means these functions are inverses. And the last new topic for the exam, transformations of functions. So now what I would encourage you to do, at least for the first two, pause the video and find f of negative x, find negative f of x if this is the graph of f. So hopefully you've completed that example. And now this notation, f of negative x, is asking me to negate all of my x values. So any ordered pair, xy, becomes the ordered pair negative xy. So now this ordered pair is negative 2, negative 1. If I make the x value the opposite sign, positive 2, negative 1. This is the ordered pair negative 1, 2. If I negate the x value, positive 1, 2. And this is the ordered pair 3, 3, which means we're going to have the ordered pair negative 3, 3. So here is my new function after a reflection over the y-axis. Now the key is recognizing that as a reflection over the y-axis. The next example, negative f of x, you have to recognize, regardless of the shape of the graph, that this is a reflection over the x-axis because the y value is becoming negative. The rule for reflection over the x-axis is that any order pair xy becomes the order pair x negative y, meaning make the y values the opposite sign. So same function f, this is the order pair negative 2, negative 1, so negative 2, positive 1 after a reflection in the x-axis. This is the order pair negative 1, 2, which means we have negative 1, negative 2. 3, 3 becomes 3, negative 3. And here's our new function after a reflection in the x-axis. Again, this is the key, recognizing that as a reflection in the x-axis. Give you a moment to work on these two, so please pause the video, work with the same function, and reflect it over the line y equals x, and find f of x plus 3. So now that you've completed those, the reflection over the line y equals x, you need to recognize f inverse of x as your cue to reflect over the line y equals x, which means any order pair xy is just a switching of the x and the y. So this was the order pair negative 2, negative 1, which means we'll have negative 1, negative 2. Again, we're just switching the x and the y values. This is the order pair negative 1, 2, which means we'll have 2, negative 1. This is the order pair 3, 3, which means we'll have the order pair 3, 3. So here is our new function after a reflection over the line y equals x. Alright, so if we wanted to find f of x plus 3, the key here is recognizing that this is a horizontal translation because the x value is being manipulated. So we know it's going to move left and right. But the hard part here, recognizing that it's moving in the opposite direction. Although it's a positive 3 in the parentheses, we're moving negative 3 in an x direction, which means all ordered pairs xy becomes 3 less than that previous x value, same y value. So this is the order pair negative 2, negative 1. So we're going to move this to the left 3. 1, 2, 3. We're going to move this to the left 3. 1, 2, 3. And again, that's all because of the plus 3 in the parentheses. This is moving left 3. 1, 2, 3. And here is our new graph. And that is f of x plus 3. Here's a couple more. Pause the video and please find f of x minus 2 and 2 times f of x. So, if you've completed this correctly, you should have recognized that f of x minus 2 is asking you to move the graph down 2. It's a vertical direction because the y value is being manipulated. However, the previous example, we were moving in the opposite direction. When you're translating in a y direction, it's the same sign. So this is moving down 2. So we'll take all of these order pairs and move them down 2. 1, 2, 1, 2, giving us a new graph which looks like that. Now if we wanted to dilate 2, the key here is recognizing that we're multiplying all of our y values by 2. We're not changing any of the x values. This is the order pair negative 2, negative 1. If we multiply the y value by 2, we're going to have negative 2, negative 2. The x value did not change, only the y value did. Negative 2, negative 2. This is the order pair 1, 2. Sorry, negative 1, 2. If I multiply the y value by 2, I have negative 1, 4. This is the order pair 3, 3. If I multiply the y value by 2, 2 times f of x. Then I have 3, 6, 4, 5, 6. So here is the shape of my new graph. Last example, we can also dilate 2 in an x direction. So take a moment and find f of 2x. If you've done this correctly, you should have recognized that the x value is being multiplied by 2 now. So this is the order pair negative 2, negative 1. If I multiply the x value by 2, I now have negative 4, negative 1. This is the order pair negative 1, 2. If I multiply the x value by 2, negative 1 is the x value. Negative 1 times 2 is negative 2. Same y value. This is the order pair 3, 3. The x value is 3. 3 times 2 is 6. So my new x value is 6. And same y value. So here is my shape after a dilation factor 2 in an x direction. So hopefully this helps you prepare for your exam, because Monday's exam will be the last test of the first quarter. So it'll be very, very important. Good luck, and if you have any questions on this video or any topics we've covered, please see me in Extra Help.